known as Galois field, is a field with a finite number of elements. Finite field are critical to the success of many cryptographic algorithms. The finite fields are completely known. It can be shown that the order of a finite field, number of elements in the field, must be a power of prime p to the power n, where n is a positive integer. For given prime p, the finite field of order p, gf, and here gf is the finite field or Galois field, is defined as the set zp of integers 0, 1, 2, dot dot p minus 1 together with the arithmetic operations modulo p. Here are some values for a plus b mod 2 and a into b mod 2. Here you can see for a plus b mod 2, here is the table, and for a minus b mod 2, here is the table. The elements are 0, 1, 0, 1, and the first row is 0, 0, and the second row is 0, 1, and here for a plus b mod 2, the first row is 0, 1, and the second is for 1 and 0. So this is the important thing to notice, that a plus b mod 2 is equivalent to a x or b, and a into b mod 2 is a and b. Another useful feature of arithmetic mod 2 is in the field z2, 0, 1 are the elements. There is only one inversion possible, like 1 by 1 equals 1. So division is the same operation as multiplication, and the field z2 is an important tool to analyze certain cryptographic algorithms by computer. We will not discuss this point because this is for the applied part, and here we are discussing only the basics of the modular arithmetic, not the application in the field of computers and all. But this is important to understand that there are the large applications of the modular arithmetic. Here z is the set of all integers, and we have seen that Zn is the set of integers mod n. Z10 equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and Zn is defined as the set of mod n integers that are relatively prime to n, and here Z10 equals 1, 3, 7, 9. So this is the symbol, like suppose we have Z10 equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and here Zn to the symbol is defined as the set of mod n integers that are relatively prime to n. So here we have only the 4 elements 1, 3, 7 and 9. 0 is missing because the greatest common divisor 0, 10 equals 10.